Hey everybody, welcome back to Young Engineers of Today. I hope you're ready to continue with Raspberry Pi because that's exactly what we're going to be doing today. We should be probably finishing off the Sense Hat today, if I were to hazard a guess, and then we'll move on to something different on Monday. But we'll figure it out. So let's go ahead and let's pick up where you guys left off on Monday. So as I understand it, you got through the pseudocode for the game. So just as a quick review, obviously we'd have to import the required libraries. Then you'd create the sense object, just like we've always done with the sense hat, import sense hat, and sense equals sense hat. That's what those two things are. And set up the colors that you need. Then you create 3 different arrows using the colors, white, green, and red. Then you set a pause variable, so between turns. Create a score variable and an angle variable to be used later. Create a variable called play set to true. Then begin a loop, a forever loop, but not really a forever loop, just a loop that continues as long as play is equal to true. Then you set an angle, show the arrow, and then check whether the orientation matches the arrow. So if it does, then add a point and turn the arrow green. If otherwise you set play, if not, then you set play to false and you turn the arrow red. So basically you have an opportunity to turn the arrow towards the orientation that they tell you to within a certain amount of time. And in this case, pause. I believe. Anyway, if you manage to do it in that given time, then you get a point and you continue the game. Otherwise, the game ends and that's your final score. Shorten the pause duration each time slightly, pause before the next arrow, and then when loop is exited, display a message with the score. So that gave us sort of a very quick run through of how this program is going to operate. Nothing too crazy, in that I didn't go into too much detail on it, but we'll spend some time walking through the process now and translating it over to Python so that you understand what exactly is going on and hopefully get a better idea of why we're doing it. So this is the beginning of our actual code. So we've actually got a couple more libraries we've got to import. So let me go ahead and move this down. And we're going to, obviously we've got our sense hat import sense hat, and I'm still zoomed in on this. Yes, I'm still zoomed in on this. But we're also going to do from time import sleep, which is going to allow us to spend some time in between functions, like allowing the CPU to pause. It's called a sleep because in essence, it's sleeping. It's not doing anything. And from random import choice, from random import choice. This is the random library, so the random number generator, things like that, or pseudo-random number generator. And choice is going to be our one of the libraries in that. So we've got our sense equals sense hat, just like we had before, and then we got to set up the colors. Now you'll notice that you've got this. I can say set up the colors, and it kind of freaks out. But if I put a pound sign in front of it, or a hashtag, or an octothorpe, or whatever your nomenclature is for this symbol, it turns green. And for those of you who are unfamiliar with why something like that might happen, this is called a comment. This is essentially kind of like writing notes in the margins of a book, or leaving a post-it note on something that you need to remember. Like remember to take lunch to school, and so you'll stick a post-it note on it, so that next time you come across it, you go, oh yeah, I need to take my lunch to school, or whatever. Basically, they are notes for you and anybody else who might be reading this program later on, so that they know what was going through your head as you were doing specific things in the code. So in this case, we know that we want to set up the colors: white, green, red, and empty. And remember, empty is just that black color. Well, that could be interesting, Liam. Yeah, I'll float that by Mr. Dubik as well. I think that could be neat. Oh, yeah, comments might be red on your Python shell. They might not be the same color. Just as long as they change to a different color when you add that, and the whole comment is one given color. Now this is also a single line comment. So if I start typing down here, this is not commented. So I'll have to stick another one in front of there. There are multi-line comments for Python, I believe, but I don't remember what they are right now, unfortunately. But yeah, so we've got white, which is equal to 150, 150, 150, because it's going to be not blindingly bright, but decently bright. Then we've got green, which is equal to 0, 255, 0. So that's going to be a blinding green. Then we got red, which is equal to 255, 0, and 0. And then we've got empty, or E, which is going to be equal to 0, 0, 0. Pretty straightforward because there's going to be no light. Empty is just, in our case, the absence of light. So we've got white, green, red, and empty. And white is not full value so that it's easier to see the other colors against it. So now we got to do something that's a little bit time consuming. We have to create images for the 3 different colored arrows. So we're going to have arrow white is equal to, and you don't have to, well, actually, let's just do this. Set up arrows. There, now we've got, yeah, now I've got a comment for what we're doing here. So arrow white is going to be formatted like so. I'm just going to paste this into the chat. And I'm going to paste it into my code. So there, now we've got, we've got our 8 by 8 matrix showing the arrow properly, and it would be a little bit easier to see actually if I did this. But yeah, so empty, 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 white, 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 and then empty to fill in the areas over here. Oh, okay. Well, it'll just take a minute then, unfortunately. Yeah, that's unideal. So we've got arrow white, and then we've got arrow red. Same deal. Let's go ahead and put that in there. The nice thing about red arrow incoming, same structure as the white one, just replace all of the instances of W with R, and you've got a red arrow. But the nice thing about this font is it's monospaced, so we can vary. Whereas over here, like it looks like arrow red is slimmer, like maybe there's there are some missing letters or something like that. But in a monospaced font, everything has the same size, so we can tell very easily that we're not actually missing any columns. Those are all of the letters representing all of the different areas. Why we went from white to red to green? No, I don't know. Just to mess with you guys, I guess, because we've spent so long white, green, red, but white, red, and then green. Arrow green equals same deal. Boom. Oops. There we go. Now we've got our green arrow. I don't even really need to copy paste it from the slides anymore anyway. I could just copy paste it from the other parts of my code and replace the necessary letters. But these build our three arrows. So we've got white, red, and green. And I'll give everybody just like a few minutes to get that set up. Go ahead and raise your hand once you've got all three arrows in your code. We'll wait for at least a few more hands. And just again, as a reminder, raise your hand once you've gotten all three of these arrows in your code. Does anybody have any questions about what exactly, like any part of this at all? No worries, just asking, just in case you guys do. They are, but the order isn't actually too terribly important. I could actually just cut out this green arrow and stick it in between the white and the red so that it matches the order up there. That was more just a commentary on how the slides were arranged, but yeah, on my code they are white, red, green. All right, it looks like we've got just about everybody. So I'll go ahead and move on to the next point. Just to be entirely, I just want to make sure that we're all on the same page. If you're still working on it, no worries. You can get to this part whenever you do. We can always double back to it if you need to as well. So the next thing we're going to do is we're going to initialize all of our other variables. So we've got pause, score, angle, and play. Those are going to be our the other variables that we use for this game. They're not colors, they're not arrows, they're not anything like that. So pause equals 3 because it's going to be 3 seconds. Score equals 0. Angle equals 0. So angle, obviously they're going to start out with a score of 0, because you're going to be starting from the bottom. Angle is going to be 0 because we're going to randomize that anyway, so we don't have to worry about, initializing it with a value. And play, but it's always good practice to at least put a value in there. Play equals true. And notice how I used a capital T on true, just so we know that it is the true Boolean value as opposed to the true string value, which is a very different thing. So play is equal to true. And next, we're going to introduce the player to the mechanic by saying it with a message. Show message. So we've got pause, score, angle, and play all initialized, and now we're going to show a message to the player. I'm just going to say, keep the arrow pointing up. No worries, Jasper. This is all being recorded anyway, so you'll be able to check it out on YouTube. But basically, we've just gotten started with the arrow game. Initialize some colors and some arrows in order to draw those on the screen. But we'll still try and at least walk through everything so that what you do see coming in will still make sense to you, hopefully. So yeah, we want to keep the arrow pointing up. And we're going to set the scroll speed of 0.05 and a text color with a U because it's all British. I don't know why I said it like that, of 100, 100, 100. So it's going to be that same not quite blinding white color that we've used for our white. No, it's less so. So it's a little bit dimmer. So yeah, that's going to be our sense show message. So sense.show message quote, keep the arrow pointing up, end quote, comma, scroll underscore speed equals 0.05, comma, text underscore color with a U because it's all British. I did it again. Equals open bracket 100 comma 100 comma 100 comma close bracket close parentheses. And if you guys remember, this is going to be the value that we show. I mean, I know I said it already anyway. Value that we show, the speed at which that message scrolls, and the color of that message. Arg. And we'll keep it on this for just a second. I'll sort of wiggle it back and forth. Okay, so that's going to be how we introduce the player to the mechanic. Why the square bracket? Because we've already got the well, because we can use both, I believe. Let me try and compile it and see what happens. Yeah, it's because you can use both. So we do it for readability's sake. Because if you start using a whole bunch of parentheses, it can be a little bit more difficult to keep track of. In this case, it's only 2 sets, so it wouldn't be a huge deal. But this allows us to sort of visually separate the brackets that the text color exists in versus the entire show message call. Yeah. So now we get started on the actual play loop. And this is going to be, well, this will get more and more complex as we go along. But so while play, this is going to be our main gameplay core, like our core loop of our gameplay. As long as play is equal to true, then we're going to stay inside of this while loop, which means that we're going to put all of our repeating game stuff in here. Now notice how it just says while play, and then it has a colon. It doesn't have, I know I haven't, I'm saving it for later. You might notice that it doesn't say like true while play is equal to true. This is a shorthand for that. This assumes that what we're asking is the contents of play, the variable play, are going to be the Boolean value of true, or a 0, 1, or a 1. Which is another computer science, basically just convention. But true, as long as it's true, then the value of play is true, and so this becomes a while true. So now let's get started on it. So last angle is equal to angle. Pretty straightforward. We just have a variable called last angle, and we fill it with the angle variable that we've got here. So the first time this runs through, that's going to be 0. Then while angle is equal to last angle, angle equals choice 0, 90, 180, and 270. Oh, sure, yeah, here's the end of the line. Let me know when you're good to go so I can move it back over. I know, I moved it over a little bit for a moment, but we'll move it back. Just so that for sure. Okay, so, all right, boom. What? But so the idea here is we set last angle to be equal to angle. And while those two are the same, we set angle to a choice, either 0, 90, 180, or 270, one of these four. And the whole plan behind that is we want to make sure that we pick a different angle than we did last time, because first of all, this forces us to pick a different angle. But if it happens to pick the same one that it did last time, well, this will still be true, so it'll run this again. It'll keep running this until angle is no longer equal to last angle. So that means that every time it grabs a new angle, it will be a new one. Then we're going to sense.set rotation angle. We're going to set the rotation of the sense hat to that angle. And we're going to sense.set pixels arrow. Oh, wait. White arrow. Why aren't you? Is it arrow underscore white? Must be arrow underscore white. There we go. Yeah, arrow underscore white. So sense.set rotation angle and then sense.set pixels arrow underscore white. And what that does is it rotates the display. I mean, it rotates the whole sense hat, but it's expressed in the display. And then it draws the arrow the same way it always does, but just the display has been rotated. So from our perspective, it looks like it's rotated. And then we're going to sleep for pause seconds. Remember, that's 3. So create a new angle. That's done with these 3 lines here. Set the rotation to that angle. Draw the screen so that the arrow is properly rotated to that angle. And then sleep for 3 seconds. And that 3-second sleep is where our player is going to try and orient the sense hats in order to make sense with the arrow. So now we've done sleep. It's accelerometer, or acceleration is equal to get sense dot get accelerometer raw. So now we're getting the acceleration. So from random import choice doesn't work for you? Or choice doesn't work down here? Also, how did you spell it like I did? Okay. Alrighty, well, there you go. So yeah, this is going to, actually, let's do this, and we'll say get the orientation of the sense hat. So now we have a comment describing what we're trying to do here. So we'll grab the x, y, and z values. X equals acceleration x, y equals acceleration y, and z equals acceleration z. Boom. Now we've got our x, y, and z values of our sense hat orientation. And we're going to round x. Oh, wait. Okay, no, it's x equals round x0, and y equals round y0. And what these are going to do is they're going to strip off all of the extraneous decimal points that exist in the raw values of the accelerometer. So instead of it being like 0.59112368954389, it's going to round up to 1, just 1, no decimal place. Same with if it's 0.32896518439778655612, it'll round down to 0. That way we get rid of a lot of the error in our measurement of whether or not the sense hat is pointed in a particular direction. So then we're going to print angle, we're going to print x, and we're going to print y. And remember, the print value gets printed out to the console. So this isn't going to be anything that the user sees, presumably. Think of this like your debug messaging. So get the orientation of the sense hat is acceleration equals sense.getAccelerometer raw, x equals acceleration x, y equals acceleration y, and z equals acceleration z. Then we round x and y to the 0th decimal place. And then we print angle x and y to the console so that we, as programmers, can see maybe what's going on there in case something is going weird. Then we've got our check. This is where we check and see if the user has the sense hat oriented correctly. Boom. Same deal, just a comment. So we're going to say if x is equal to -1 and angle is equal to 180, then sense.set pixels arrow green and score is plus equals 1. So if x is equal to -1 and angle is equal to 180, what does that mean? Well, angle equal to 180 means that the sense hat is pointing the arrow in the opposite direction. X being equal to -1 means that the sense hat is oriented in that direction. It's pointed downwards, I believe, back or upwards, so the back is pointed downwards. And that's how we know that, well, that's not how we know, but that would be the correct orientation for the angle that the sense hat is looking for. So then it sets the arrow to be green, and it adds 1 to the score. And this is simply a shorthand for doing equals score plus 1. That is simply all score plus equals 1 is. We could do score plus equals 2. We could do score minus equals 1. We could do score times equals 5. You can modify this little shorthand to represent whatever you need it to, which is nice. But for now, we're just going to add 1 to it. So to score. So score is going to be equal to score plus 1. Then we're going to say else if, that's what ELIF is short for, is just else if x is equal to 1 and angle is equal to 0. So as you can see, angle is the opposite of, or 0 is the opposite of 180. So this angle is the opposite of this angle. It's the other side of the circle. So we want our x value to be the opposite of that as well. So now the front end is tilted downwards. So yeah, if x is equal to 1 and angle is equal to 0, then same deal, sense.set pixels arrow green score plus equals 1. Pretty straightforward. Now we do it for y. So else if y is equal to -1 and angle is equal to 90. So y is equal to -1 and angle is equal to 90. And sense.set pixels is equal to arrow underscore green and score is plus equal 1. Same deal as we got up here. If y is equal to -1 and angle is equal to 90. So in this case, we're checking y now because y is, or excuse me, 90 degrees is at a right angle to either 180 or 0. It's perpendicular. So we want to check the perpendicular axis. Finally, else if y is equal to 1 and angle is equal to 270, sense dot set pixels arrow green score plus equals 1, because angle 270 is on the opposite side of the circle from 90. It's also perpendicular to 0 and 180. It's just on the opposite side of the circle. So we want to make sure that we ask for the reverse of the y-axis. So for now, we've got, let's do this. Boom, boom, y and x, 1 and -1, and 1 and -1. And then there are these arrows, and here is, I'll draw the circle inside of it. So 0, whoops, 90, 180, and 270. So this is what our circle looks like right now, and this is why we're checking it. I'll let you get there. But I just want to explain why we're doing this for a second, and then we can get right back to it. I'm not gonna skip over it entirely. But this is the relationship between the x and y axes. That's why we're checking x or y on a specific angle. So x was 0. If it's asking for 0, then the arrow is going to be pointed this way, and we want to make sure that we tilt the sense hat downwards so that it registers the correct value. If angle's at 90, as you can see, it's perpendicular to 0, so we want to check the y-axis and make sure it's -1. Same deal with 180, except it's x is -1 and y is +1 if it's 270. So we'll get you back over to the code over here. It's not the end of the world. So these are our 4 if statements, and if and else if. There's going to be one final else statement after this, which I'm going to throw in there real quick, and then I'll give everybody an opportunity to type all this stuff out. So else sense.set pixels arrow red, and what is it? Play equals false. So this is our entire if statement block right here. What this last one does is basically if none of these are true, so that's to say that the sense hat is not oriented in the proper direction, then make the arrow red and set play to false. And if you remember, setting play to false means that the loop is no longer valid, and so it will drop out of the loop. So this is the way that we end the game. But yep, I'll give everybody a couple of minutes to type this up. Just go ahead and raise your hand once you're done with this block. Just wait on a few more hands. So it'll be just a few more minutes. Oh yeah, no worries, Jasper. There are a couple of other people though, so no, no problem. You're all in the clear. I appreciate you saying that though. Remember that that indentation is important too. So the indentation gets a little bit wonkier here because everything is already indented one tab. So that means that everything inside of the if statements is indented two tabs for each if statement. So it goes back to one tab for the next if statement and then for two tabs for the contents of that if statement. Okay, so that's mostly everybody. I'm gonna go ahead and I'll keep moving along. Again, if you want me to go back over anything, just let me know. So we're going to do two more things before we start getting out of this loop. We're going to pause. We're going to decrease the length of time for pause. So pause is going to be times equals 0.95. What this is going to do is it's going to multiply pause each time by 0.95. Pretty straightforward. It means that pause each time is going to be 95% of the size that it was. So it's going to be shrinking by a little bit each time. So the sense hat will just ever so slowly speed up a little bit by little bit by little bit by little bit by little bit. And then we're going to sleep for half a second in between. There we go. In between loops. So that at least it'll sit there and show you the color of the arrows that you know. You can process it. Now you'll notice that we're no longer indented. That was the last bit of this loop. So while play is going to do all of that stuff. Now we're going to say message equals your score was %s and then %score. Interesting. Okay. Then we've got sense.show message, and it's going to be message, and scroll speed is equal to 0.05, and text color is equal to 100, 100, 100. So now we've got our final score. So we're going to shrink the pause by a little tiny bit each time by 5%, and then we're going to sleep for half a second, and that's going to finish out our loop. And then outside of the loop, we're going to have our final score message. What this is going to do, your score is %s. Basically, the %s is going to be filled in with our score value, just like we did with the brackets 0, bracket 1, bracket 2 in the I believe it was the OMG one, if I remember correctly. It was something. Anyway, but it'll fill it in with the score value because we've denoted that over here. And then sense.showMessage is going to show our message with a scroll speed of 0.05 and with the text color of sort of that darkish white. And that is our program. And if you were to run it on your SenseHat, you would see that the SenseHat requests that you tilt the Raspberry Pi in a specific way, and then you just follow its instructions. You tilt it, and you just got to make sure you tilt it in the direction it tells you to, and then you'll get a point, and it'll do it again. And the difficulty comes in from the fact that it goes a little bit faster each time. So eventually, it's going to be going really, really super duper fast, and you're going to start practically don't actually do this, but practically flinging your SenseHat around, trying to keep the orientation exactly as it asks you to be. But that is our whole program. So, like I said, I'm going to let it sit here for a couple of minutes so everybody can get finished off with the typing. If you have any questions about anything, you're more than welcome to ask them right now. If you want to give yourself a couple of minutes to test it while we're finishing up and you're already done, then feel free. If you've typed it out and you tested it and it ran and you're happy with it, then go ahead and raise your hand. Otherwise, I will go ahead and start asking the poll questions at about 7:52-ish, so in about 3 minutes, and we'll start wrapping up from there. Your arrow is not changing. So did you? Whoops. When you said while angle is equal to last angle. So like I've got up here in line 59, did you use a single equal sign or a double equal sign? Double. Oh, okay. And you set angle equal to choice. And did you sense.set rotation with angle? Let me see what I got here. Oh, keep the arrow pointing up. Boo. Hmm. Is there different? Okay, well, it is changing for me. Let's see here. Do you get any errors when you're trying to, like any warnings or anything like that when you try to run it? Hmm, it's bizarre. Um, that should be all that you have to do. Oh, that might be it. Um, do you, is there anything in the console right now for the Raspberry Pi? No. Sorry, the console, the console. The how do you run your Python programs? Yes, no, but specifically, do you run them through the terminal on the Raspberry Pi, or do you just save and run them on the Python shell? Like basically, when I say that this stuff prints out the console, where do you where do you go to check that stuff? Okay, run it from the shell and see if the shell spits anything back out to you when it freezes like that. That would be your first place to check. Oh my goodness, I have to do the poll questions. Okay, so we're gonna go ahead and do the poll questions, and then we'll leave it open for question and answer time for just a couple of minutes, and then I'll try and get you guys out of here before 8, so that uh okay, that sounds good. So that we can let you guys out a little bit early, and I have enough time to get ready for the high school class. So that's gonna do it for today. I hope at least you found it interesting, enlightening, something. Um, And once we're done with the poll questions, then you guys are more than welcome to head out and have a wonderful weekend.